Hi, everybody. So, as I said at the beginning of the lecture, the timing might be a bit off. So, today's lecture went a bit slower than I had hoped, and we're 2 lectures in and already behind. So, to make sure we don't fall too far behind, I'm going to do the rest of this lecture as this short video. Fortunately, we were almost done, and we had mostly finished a lot of the substantive stuff anyway. So, when we finish, we were just talking about why use all the mathematics if Lord Baelish can model in this way that all of us will be familiar with when we just try to simplify a problem down to its most important elements and try to understand what's going on in that problem. Why do we need all the math? And the reason that we need all the math is, again, as I said in the lecture, that it helps clarify our thinking. It helps us from fooling ourselves. The mathematics don't lie. And there was a very good question in class that, the Rogoff and Reinhardt paper seemed to have been a lie, but the math didn't lie there. It was the people, not that they lied. They didn't do it on purpose. I'm not saying that, but it was a human error. It was a mistake of the researchers, not of the method that they had implemented. One difficulty with using mathematics, and this goes back to when I was talking about the meritocracy we have in mathematics, is that it can be used as a sort of gatekeeping. It can be used to keep certain people out of the conversation. So if somebody doesn't understand mathematics very well, they tend to get excluded from sort of high-level, serious economic debates. And that's not right, I don't think. It will prevent them, if someone doesn't have a good use of mathematics, a good handle on some calculus and mathematics, and they won't get to participate necessarily in the production of economic evidence if they don't know their econometrics and their calculus. But that shouldn't prevent them from understanding the implications of what has been found, the implications of what the model suggests in terms of policy especially. So mathematics needs to be translated for people that don't understand it, for the non-economists of the world, and for colleagues that maybe don't understand. Maybe your mathematics is more sophisticated than a lot of your other economics colleagues are accustomed to. It will need to be translated for them. This speaks to this idea that mathematics should clarify, complement our thinking, but it should not replace our thinking. If you can't explain what you've done in the mathematics, and you don't really understand what you've done, if you can't explain it in simple human language. One of my favorite economists, I mentioned him on Monday with the mustache. There he is, Alfred Marshall. Was very clear-headed thinker, great writer. If you want to see excellent writing in economics, read Alfred Marshall. But he thought of economics and the use of mathematics and economics in these terms, which is it is a means to an end. The mathematics is not the end in itself. And so these were his steps for building a model. So you use the mathematics as a shorthand. You use it as a way to clarify your thinking. And you keep those mathematics around until you've finished all of the steps. You need to translate the mathematics into English so that people that don't understand the mathematics and yourself can understand, well, what does this actually suggest in reality? What does this suggest in terms of social interactions? Then find some examples. Are there any examples of that sort of thing? Or is this just this really artificial situation that I've constructed? If you're able to do all that, get rid of the mathematics. They were a means to an end. So burn the mathematics. And I think that's a really good approach to appreciating the role of mathematics in doing economics. It is a tool that we use to help us think. It is not the point of doing economics. The point is not to be able to solve a model, to show what the Cournot equilibrium is, which you guys are all going to do this term. That is not the point of that exercise. The point of the exercise is to formalize that thinking and get rid of the unnecessary complexity. Now, I'm going to talk very briefly about empirical models. So talk a lot sort of more philosophically about what models are, and a lot of the sort of modeling that we are going to do in this course is going to be theoretical models, which are very important and very useful. However, they do not constitute evidence in and of themselves. They help us understand the world, but they do not themselves provide evidence as to how the world works. Evidence has to be empirical. So we have to go to data and understand what the data are telling us, and if those data are consistent with what our model suggests should be the case. So just like Lord Baelish does, he had his idea, he had his theory, and then he took it to the data. How well does his theory fit what people are actually doing and actually saying? And that's what we do in empirical work, which is really the area of economics that I work in predominantly. So using data, statistics, econometrics, all of these things that you guys are going to be learning over the next few years are a big part of what we do, and often not featured enough in sort of core economics education, but always keep the empirics at the front of your mind when studying economics. How well does this model, this theoretical model, help me understand what I actually see in the world? Building empirical models, we use models in empirics as well. We usually start with a pretty basic question about how does the world, what do I see in the world? Often it'll be a causal relationship we're interested in. So does more education cause you to earn a higher wage? So does coming to university cause you to earn a higher salary when you finish university, or would you have earned that salary anyway if you'd not gone to university? We often look for stylized facts. So these are still sort of a semi-fancy way of just saying things that tend to be true, things that we actually see evidence of in data. So one thing we consistently see evidence of all around the world is that higher educated people earn more than less educated people. And there's a number of reasons why that might be. And that's where the theoretical modeling comes in. So we have models with theories about why do higher educated people earn more than lower educated people. Maybe it's that when you come to university, you actually learn something useful that the labor market then rewards. They want you to bring that particular skill into their firm. Maybe it's just a signal of your ability. Maybe it's that if when you finish high school, it's very hard for firms to know who are the high ability people and who are the low ability people. So by coming to university and getting a degree, that is a way of telling the labor market, telling firms, look, I'm a high ability person, you should give me a job. Even if I didn't learn anything at university, university was hard, I finished it, therefore I'm a high ability person. There's several theories out there about why higher educated people might earn more. Then we go to the data. And we see, okay, is a person's wage actually a function of education? That is, do we see changes, people with different levels of education controlling for other things affect their wage? And you can kind of think of this as a recipe, right? So we observe wages, and when I say are wages a function of education, or to what degree are wages a function of education, we want to think of what is the recipe for high wages. So the function is sort of the bowl in which we're going to mix our ingredients and make wages. What are the things that go in there and in what proportions? So if I increase education by a little bit, how much would I see my wages increase? Like if you increase the amount of sugar in your cake recipe, how much sweeter is your cake after you bake it, if that makes sense? So when we do that, that sort of basic idea that wages are a function of education is number two. That's sort of formalizing that initial question. Does it more education increase your hourly wage? And the model that we write down, this is what's called a linear model for reasons you will learn in econometrics. We're not going to go too far into econometrics at all in this course. But we're saying wages equals some constant amount, which is the alpha, plus the amount of education that a person has times some amount, some number. And that number will tell us, on average, if you increase education by 1 year, wages will increase by this beta number, whatever that is. So most of econometrics is about figuring out what that number beta is. And the simplest way to think about it is the line of best fit, which you guys have all done. I'm sure in high school, at least, you've seen a line of best fit. So to do that, first we need wages, we need data. So we need data on wages. So we can do a survey. We can just go out there and ask 100 people, how much do you earn per hour? And we'll need information on how much education they have. So we can ask them, how much education do you have? How many years were you in formal education? But we collect all of that information, and then we can plot it. So this is reality. And reality, as we said, is complex. Society is complex. This is very messy, it seems. But what we're interested in is stripping away that complexity and trying to understand the relationship between years of education on the x-axis here and the wage. And one way that we do that is strip away that complexity, make some simplifying assumptions, is we fit the line of best fit is that model. Okay? We obtain this via something called ordinary least squares, which again you will learn about in econometrics, about how to actually fit that and how to obtain an estimate of beta and an estimate of alpha. But this is an empirical model. It's an abstraction, it's a simplification, it's focused on a single mechanism. That is exactly what we said a model was at the beginning. So we have theoretical models, we have empirical models as well. Now, what are empirical models good for? So when we have our theoretical models, we have sort of two things that really need testing. We have the assumptions and we have the predictions of the model. So what are the expected outcomes given that those assumptions are true? And we can use empirical models to test both of those. One thing that empirical models are very good at, and that sort of economics or economists in general, applied economists tend to be very good at, is picking out causality. Does X cause Y? Does more education cause you to get a higher salary, or is it just correlated? But this is important, I think, when thinking about models and what it is we use models for. So if you look at the picture on the left where it says cause, models are pretty useful for saying, if you stab him with this needle, if you give this kid a shot, we have a pretty good idea of what the effect will be on average. So we can make some predictions, some expectation that given the shot, and you'll get the kid that's crying. Okay, that would be the direction of understanding that models help us with. On the right, where you just see the effect, what we're less good at is looking at a situation where you see the kid crying and you want to know, well, why is he crying? We have some evidence. It looks like somebody gave him a shot. But what we're not great at with the models is these causes of these effects. So yes, it looks like he got a shot. Yes, he's crying. Does that mean the shot is what made him cry? No, not necessarily. We don't have enough information about this situation. Maybe his favorite football team just lost. Maybe his father took away a piece of candy from him just before he got the shot. Any number of things could have happened that led to him crying. The shot could be one of them. But just because we see that he got a shot and we see that him crying does not mean that the shot was the cause of him crying. Whereas we're better at understanding the effects of particular causes. If you give him a shot, there's a high probability that the kid will cry. So if you're interested in reading more about this, effects of causes versus causes of effects, this article by Gelman and Imbens is really interesting, I think. All right, just to finish up, this is one of our heroes, Danny Roderick. You guys have a chapter from his book to read. I can't recommend the rest of his book highly enough. It's called Economics Rules. It is a great way to really understand what it is we do as economists. I don't think there's any math in it. It's really just about understanding what economics is, how we do it, why we do it, when it works well and when it doesn't work well. And one of my favorite things that he says in the book is that we have a model, but it is never the model. So as I said, all models are wrong. Some models are righter than other models. Some models are righter in particular contexts, and they're really wrong in other contexts. So when you're learning about models, keep in mind that you're learning a process. You're learning a way of thinking. The individual models that you're learning are less important. The real key to get out of what you're going to be doing over the next, in the next 8 weeks with me, but over the next 3 years at university and studying economics is thinking via models, using models to formalize your thinking, to prevent you from fooling yourself and to help you convince other people that your line of reasoning is in fact right. Okay, that's all. Sorry for going over time. I will hope that we don't do that, but I can't make any promises, but I will do my best and make amendments as we go if I think lectures are going to end up being too long. So hope this helps. Bye.